On our second page, we start getting into more of those systems of equations where it tells us how to do it. This says solve by substitution. And a lot of you really need to pay attention to these next two problems because it's our weakest area, okay? It is it's a very, very good mathematical tool, but it's one that a lot of people shy away from. Thankfully, both of these problems are set up for substitution. And what do I mean by that? I mean that X is already solved for there and Y is already solved for there. In other words, we have a variable all by itself. That's what lets me know substitution is a good idea, okay? So I didn't even make it a really complicated one. I made it one that's nice. It's already set up for you. But you have to do it both ways. X equals 2y plus 2. So I know what X equals in terms of Y. That means I can take this information and plug it into my other equation for the letter X. When I do that, rewriting my first equation, I get 1 equals -2. And then I'm going to plug in our other piece. 2y plus 2 in red, and then I'm going to continue writing the equation, 9y. You'll notice we went from two equations with two unknowns, x's and y's, to one single equation, and yeah, we have two variables, but they're the same variable. That's only one unknown variable. So I went from two equations, two unknowns, to one equation with one unknown. Now when I continue this problem out, 1 equals, this would be a -4y, don't forget, a little distribution here, okay? -4 plus 9y. Notice my distribution did not go to the very back term. That's because it's not in the parentheses. When I combine like terms here, I get 1 equals 5y minus 4. When I add 4 to both sides, I get 5 equals 5y, which means that y equals 1, because I would divide by 5, divide by 5. That is half my answer. Okay, so if I'm going up here and I'm writing my answer, that's my y value. Now I have to take this and plug it back in. I'm going to plug it into this bottom equation here. I'm going to do that because I want to find X now. And X is already solved for here. So I have X equals 2, my Y value of 1 plus 2. Well, 2 times 1 is just 2, so I have 2 plus 2. And then I have X equals 4, meaning my answer is 4, 1. Now, you can go back and check that. I would strongly advise you to. Maybe you're good at graphing them. Well, then solve these out and graph them. Check your answer. Maybe you're good at elimination. Line them up, eliminate them. Okay? Check your answer. You can also just plug these in, and that's some mental math that a lot of us can do. Plug in a 4, 1. When I plug in a 4 right here, I get -2 times 4, which is -8. When I plug in a 1, I get 9. -8 plus 9 is a +1. It worked. Here I want it to equal 4, so I'm just going to plug a 1 into my right side. 2 times 1 is 2. 2 times 2 is, or 2 plus 2, sorry, is 4. It worked the same. 2 plus 2 is 4, and that's what I wanted to equal. That answer worked. Okay, just quick mental math there. On my second problem, I see that y is solved for itself. That means I can take this chunk, what y equals in terms of x, and plug it in for my y value. Rewriting my original problem, I have 3x plus 7y. Well, I don't use y anymore. I'm using 2x minus 3 for that. Okay, so I just plug that part in, and then I continue on with my equation. So all I've done is rewritten this second equation, but exactly where the y was, I've replaced it. Notice the 7's still there. 7 didn't change. Exactly where the y was, I have now replaced it. Okay? So whenever I continue working this problem out, I have 3x, little distribution here, 14x minus 21 equals 13, little distribution right there. Okay, 14x, negative 21. When I combine like terms here, I'm going to get a 17x minus 21 equals 13. So I'm going to add 21 to both sides. I get 17x equals 34. When I divide by 2 and divide by 2, I get that x equals 2. That is half my answer, okay? So if I'm writing my answer, I've got a set of parentheses, and my x equals 2. Well, to find out what y equals, I take that information, and I go plug it into one of my equations. Again, I'm going to use this top equation, okay, not again, but I'm going to use this top equation because I want to find y. And y is already solved for here. So rewriting this top equation, I'll have y equals 2, and I'm plugging in this x value. of a 2 minus 3. So I'm using this top equation, just marking that one out so no one gets confused. 2 times 2 is 4. 4 minus 3 is a 1. So y equals 1. There's my answer. You can do the mental math and check that again. Take a 2 and plug it in. For x here, that'd be 2 times 2, which is 4, minus 3 is 1, and it's supposed to equal 1. That worked. In this marked out equation that we have, plug in a 2 here, I get a 6. Plug in a 1 here, I get a 7. 6 plus 7 is 13. It worked. Okay? 8's a really good problem. We haven't really tackled a whole lot like it, but it's in your wheelhouse. It's something you should be able to do. So we've got all these fractions, and we don't want any of these fractions, so we have to get rid of all of them. Now, most people just look at the denominator and think, oh, let's multiply by 2. But if I multiply by 2 here, I'm going to get a 1. That's good. But if I multiply by 2 here, I'm still going to get a 1/2, and it's not going to work here. If I multiply by 3, it's not going to work. Multiply by 4, it's not going to get rid of all of them. You can try it, okay? It's not going to get rid of all of them. So we have to find a bigger number that all of these are going to go into, okay? I need a larger number that 2, 3, and 4 will all go into evenly, all right? I want their least common multiple. Now, that number is 12. I get that because 3 and 4 have to go into it, and then I need it to be even. That's kind of your train of thought there. 3 and 4 go into 12, and I know 2 is going to also go into 12. So I'm going to multiply this entire equation by 12. Bigger numbers will work. They're just going to make your coefficients larger. That's not really the end of the world, but we always want to use the smallest one that we can think of. 12 times 1/2, that's a 6x. 12 times 2/3, that's an 8y. Put that in the calculator, please. Don't just trust me on that one. Whenever you're doing these yourself, put in a 12 times 2/3 just to check it, okay? Please be careful there. That is an 8y. And then equals 3. And that's your answer, guys. That's all there is to that problem. That's it. 9's very similar. We just want to get rid of these decimals. Most people look at this and go, oh, multiply by 10, okay? And this is going to just say integers whenever we actually print the actual test out. Technically, this says integer coefficients. There's an argument whether you could call this a coefficient or a constant, you know, things like that. But if we want all these decimals gone, most people look and go, oh, let's multiply by 10. I'm going to tell you right now, that's not going to get rid of all of them. That'll end up with a problem like 5x plus 2y equals 2.5. And that's not the end of the world, okay? We would just need to multiply it through by 10 again. That's going to give us 50x plus 20y equals 25. To avoid all that, you could have seen from the beginning, this is a tenths place, but this one goes to the hundredths place. And to get rid of something in the hundredths place, you need to multiply by 100. When I do that, it's going to give me a 50x plus 20y equals 25. It's the same answer either way. Just please make sure you get rid of all the decimals on that problem. All the decimals.